Okay, so my name's NASA, and I'm going to do a short series called What Will Come Up in the Exam, specifically for the 9 to 1 AQA GCSE exams which are coming up. And I'm going to look at things that come up most often, and this will help you students focus on what really tends to come up and what to expect. So let's start specifically with some foundation level questions. Now, things like this, you're going to get some multiple choice questions in your exam. The foundation, you'd get more of the multiple choice questions than in the higher. In the higher, you'll get a few. Okay, so in this case, you've got one about structure and bonding. And it shows one layer of graphene. I guarantee you are going to get a question, and something similar to this is going to be on. It's either going to be on giant covalent molecules, or this one graphene or graphite. Graphene is just, whenever you see that, just think a single layer of graphite. Okay, so what is graphite? Graphite is this this continual massive molecule of carbons bonding to each other, with each carbon bonded to 3 other carbons. But as you know, carbon actually is in group 4, and that means it should really bond to 4 other carbon atoms. The way it's arranged means that it has this additional electron that's not being used. And what happens is, as these go across layers, the attraction between layers, because of that, the electrons can actually move, and the layers can slide over each other because of the format. Anyway, so graphene, graphite, all of that, that's all carbon. Yeah. When they look at the they might look at these nano Buckminster Fullerene and all of that, Fullerenes, they're all forms. Whenever you see that, just think carbon. Okay, now each atom in graphene has 1 delocalized electron. Complete the sentence, and what is it? And choose the answer from the box. It allows it to conduct electricity. Now, graphene does have this sliding layers, yeah, and what is it? So, but you mustn't just get this confused and think acts as a lubricant. You need to think, what is it that electrons do? Electrons move. You see them in electricity, yeah. They conduct electricity. They carry electric charge. Okay, so the delocalized electrons allow graphene to conduct electricity, and in fact, that's the same thing that metals actually do to conduct electricity as well. Which structure is a fullerene? Okay, so a fullerene, this is what we're looking at here. The fullerene, the bottom one with the carbon, you've got these carbon atoms, they're all joined together. Is basically, when you look at, just think graphene but in a round structure or something like that. But yeah, that's that. That one up there is diamond. This one here is a simple covalent molecule, and this is an ionic compound. So yeah, the diamond and the fullerene, these are giant covalent molecules. Now, notice the difference between a giant covalent molecule and a simple one. A giant covalent molecule simply has lots and lots and lots of carbon atoms in there, all joined together. They're all joined together to form this massive structure. Whereas usually covalent molecules are quite simple. The simple ones, and then they have these, H2O is just one oxygen atom with two hydrogens. Anyway, so what about this one? However, this is another one. This is an interesting one. A large hydrocarbon. This is what's called a polymer. Yeah. So, which two elements are in all hydrocarbons? I think I can break it down quite easily. Hydrogen and carbon, those are the two elements. It tells you hydrocarbon, hydrogen and carbon. Okay, so complete the sentences, choose the answer from the box. Okay, so the large molecule represented in figure 2 is a polymer. It's important that you know these. Polymers are generally represented like this. And that basically, that N means that structure there can continue going on for, it can go up to the millions. So it's just a very, very long structure there. Complete the sentence, choose the answer from the box. Okay, metals can be stretched into wires because the layers of the atoms can slide. I think that's a fairly simple one there. All right, let's have a look at some other questions that generally come up. All right, this one is about electrolysis. Okay, how many different elements are in the formula AgNO3? Okay, so this is the paper one, for chemistry. But when it says how many elements and how many atoms, you mustn't get mixed up. That's basically the atomic theory. It's the beginning, but those ones are very easy marks to get, but very easy marks to lose as well. Is it asking for elements, or is it asking for atoms? What's the difference between an element and an atom? An element is one type of atom. So you've got these atoms, and they're all different. But what's different? The number of protons, and then the number of electrons also happens to change. So an element is one type of atom. So how many different elements are there in the formula AgNO3? Okay, so you should see in the periodic table, Ag is silver, N is nitrogen, and O is oxygen. Those are the different elements from the periodic table of elements. So how many are there? There are 3. How many atoms are there in the formula AgNO3? Now we're looking at counting the individual atoms. So Ag, there's one silver. There's 1 nitrogen. So that makes 2 so far. And there are 3 oxygens. That small 3 there means that small 3 belongs to oxygen. That means there are 3 oxygens. So in total, there are 5 atoms that make that up. Okay, so you've got here your silver nitrate solution passed through electrolysis. Okay, so it contains these 4 ions. where do the H plus and OH minus ions come from? Okay, so let's see. You want to see that this is in a solution, so this solution is going to be from the water. There's going to be water in there because that's what's going to happen in there. H and OH minus ions, those H plus and OH minus ions, they are in water. So as soon as you see that, usually in solutions, in any solution or aqueous solution, anything there, that is going to be, there's going to be some water in there, unless it's a molten solution. If it says it's molten, there is going to be no water in there. But I can guarantee you there is water there. So that's water. Ag ions and H plus ions are attracted to the negative electrode. That's the cathode. Give the reason why. I want to start off with this idea of panic. Positive is anode, negative is cathode. Yeah? So that's panic. Think panic. I'm going to panic in my exam when I come across an electrolysis question. Positive is anode, negative is cathode. Okay, so why is it that they're attracted to the negative cathode? And you'll be able to see it's because these are positive charge. Positive charges are attracted to the negative electrode. They're oppositely charged. Let's see what the oppositely charged. These opposite charges will attract the. So let's have a look at what the exam mark scheme says. Yeah, so opposite charges attract even. Okay, so silver is produced at negative electrode, cathode, and not hydrogen. What does this tell you about the reactivity of silver? Have a look at that. Okay, so silver is less reactive than hydrogen, silver is less reactive than oxygen, silver is more reactive than nitrate, silver is more reactive than water. Okay, so if silver is produced at the negative electrode and not hydrogen, that means that silver must be below hydrogen, is less reactive than hydrogen in the reactivity series. Let's double check that one. Yeah. Now this one is something you're gonna have to think about in a little more detail. And that's all to do with looking at the reactivity series there. So look at the reactivity series, and there's a general rule. If it's less, if the substance is less reactive than hydrogen, and that substance is going to be produced at the cathode. If it's more reactive than hydrogen, then the hydrogen is going to be released at the cathode. It's quite an interesting one. Okay, so the hydroxide ion, OH minus ion, is attracted to the positive electrode, the anode, and the equation shows what happens at the positive electrode anode. Name the gas produced at the positive electrode anode. So, equation, what happens at the positive one. So it's, out of this, you can see what is the gas is going to be produced. Well, H2O is certainly not going to be gas as water. You know, there's oxygen. Oxygen is the gas that's going to be produced. And then let's have a look at this one. This is an interesting one. This one comes up a few times. So the general thing here is the presence of sodium hydroxide can be shown by adding an indicator. Name an indicator. Give the color of the indicator in sodium hydroxide solution. Now, easiest indicator to think of. There are a variety of indicators you can actually use, but the easiest indicator to use, the one that you learn from year 7, and that is universal indicator. Put down universal indicator. Don't be lazy and just put down universal. Put down universal indicator, and that's 1 mark straight away. And then there's the color. Now, sodium hydroxide, anything with hydroxide, that's those are alkalis and bases, yeah? So they're going to be between pH 8 and pH 14. Anything between pH 8 and 14, those generally go up from blue until purple. Whereas 7 is neutral, which is green, and then 6 all the way down to 1, those are acids, and those go from 6 is around yellow, and then it goes orange at around 3, and then by 1 it's red. So you've got this amazing color spectrum, but it's easy to notice, okay, it's got hydroxide in, it must be an alkali, so it's going to be purple or blue, you could say, and you'll get marks for either of those. Yeah. So that's the fair one to start with. Let's see. I think I want to attempt one more. Now, this one is a very interesting question I'd like to answer, in fact. I want to dedicate a specific video to answering this type of question, but it's a 5-mark question. You need to break it down into how many electrons are being transferred, and from what to what. How many is being gained, how many is being lost. And you would write how, okay, so the potassium now, how it forms a potassium ion, and the fluorine will also form a fluoride ion. So what's that process? How does one get the negative charge? How does one get the positive charge? You're just talking about how many electrons are being lost, by what, how many electrons are being gained, and by what. And I tell you, if you can do that, it's very simple to get those marks very, very easily. See? So potassium loses 1 electron. So how many electrons are being lost, by what? So the potassium. and then you mention it forms that positive ion, and then fluorine gains 1 electron to form a negative ion. That is easy marks. Easy marks. You could do that in 1-2 sentences. Like, you see all these lines there, and sometimes people waste so much time and get nothing. In 2 sentences, you could get 5 marks straight. Don't pressure yourselves, guys. Don't pressure yourselves. When you see that, don't panic. Okay? Just remember that, and you know that's the easy way of going forward through it. So that question is definitely coming up, or it definitely comes up, like, frequently. It's just variations of the same thing. Yeah. So just to do that, just follow that step that I give you, and you'll be fine. All right, we do this one, and then we'll tidy up from here. Okay, so this question is about compounds of oxygen. So the reaction between carbon and oxygen is exothermic. What does exothermic? What does exothermic reaction mean? Exothermic reaction, it gives out energy. Yeah. Now it tends to give out heat energy, but you can see, so it gives out energy. So you could say it transfers energy to the surroundings, is what they like to hear. Okay. You probably would get a mark for saying it gives out energy, but try and stick as close to what this mark scheme gives. So it transfers energy to the surroundings, and therefore, what does an endothermic reaction do? The very opposite. It takes in energy from its surroundings. Okay, now this is important. This one here. So this is a reaction profile diagram, energy level diagrams, sometimes people call them. Okay, now for an exothermic reaction, the energy of the product is always lower than the energy of the reactant, because don't forget, it's given out that energy to the environment. So the product is always going to be the bit at the end. Reactants are what you start off with. Yeah, so it starts off with this, and this is what you end up with. This is the only graph we can see which follows that. Okay, in that process, energy is being given off. So that one is the exothermic one. This one is endothermic, because the reactants, you can see, they must have taken in energy from the surroundings for the product to be at higher energy level. Yeah, so this is your endothermic reaction. Yeah. So that one, when you feel something that's endothermic, it's gone colder, and you kind of want it to think of something as it's taking in that warmth from your hand, so you're feeling it as, as colder, is drawing away that energy. Whereas an exothermic reaction, and when it's giving out that energy to surroundings, you can feel that heat energy coming out of it. Yeah. All right. So this question, this one is really simple. Just follow the instructions. They give you the formula. They give you the equation. So all you need to do is put the stuff inside the equation. So the percentage by mass of oxygen, carbon dioxide is calculated by this equation. Okay, so the number of atoms of O times the relative atomic mass of oxygen divided by the relative molecular mass of carbon dioxide. So, how many atoms of oxygen are there in CO2? 2, because the 2 belongs to the O, so there are 2 oxygens. So it'll be 2 times, what's the relative atomic mass of oxygen? Well, it gives that to us there, doesn't it? That's 16. 2 times 16 is 32. And then you divide that by the relative molecular mass of carbon dioxide. Now, you might have to refer to my other video on learning about, how to find relative molecular mass. But they're really, really simple. All you need to do is you just take the relative atomic masses of each element inside a molecule and you add them together. And that will give you the mass of the molecule. Okay, so let's look at this for carbon dioxide. So there is 1 carbon, so that's 12, and you can actually find this in a periodic table. This is like the masses of each one. So carbon is 12, and there are 2 oxygens, okay, which is 16 each. So 16 times 2 is, as we said, 32. Add 12, that's what, 44. And so you will have 32 divided by 44 multiplied by 100. And I don't have a calculator with me. Yep, hang on a second. I do have a calculator with me. So I will give you the answer to that. 32 divided by 44 times 100, so that's 72.7%. So that's 73%. Yeah. To 2 significant figures. So all it is you're sticking those numbers in. Let's see how we did. Yeah. Okay, so 72.7%. So they wanted it to 3 significant figures. That's fine. It's very possible that you could get away with actually putting down 73% though. Because what they've done there is, if they wanted it to 3 significant figures, really they should have put 12.0 and 16.0. Don't worry about that though. Anyway, 72.7%. You can see all it is just putting this in. Balancing this chemical equation. This actual question came up more than once, I've seen this a couple times. Don't forget, questions tend to repeat themselves. They repeat themselves over and over. There's only so many times you can ask a single question. So when they say the specification has changed, the content hasn't really changed. So balance the chemical equation. Now with this one, a lot of people see it and they panic. Now this is my secret. Whenever you see H2O, make it an even number of oxygens, because it's very, very difficult to balance an odd number of oxygens. Okay, so when you've got H2O, a molecule wherever it makes things challenging. So always start by, especially if you've got 2 if you've got, you know, an even number of oxygens on the left-hand side, take that H2O and just double it to make this side even. It makes things so much easier. So you put a 2 in front of the H2O, and that means on the right-hand side you'd have a big 2 there. It'd be 2 lots of H2O, so 2 times 2 hydrogens is 4 hydrogens, and 2 times oxygens, you can see there's only one oxygen there. 2 times that is 2 oxygens, but then you've got these 2 oxygens as well, so you add these 2 and it makes 4. I'm gonna do a video on this one, actually, balancing equations, because a lot of people can get confused on that. There are tons though on YouTube, so I recommend you have a look at that. So we'll have, once we put a 2 there, we're going to have 4 hydrogens there. How can we get 4 hydrogens here? If we put a 2 here, then 2 times H2, that will be 4 hydrogens, and then that 2 also multiplies by that 2 oxygens to give a total of 4 oxygens, and that balances out with the 4 oxygens that will be on this side. So yeah, look up some videos on balancing equations. And then 6.8 grams of hydrogen peroxide decomposes to produce 3.6 grams of water. Calculate the mass of oxygen produced when 68 grams of hydrogen peroxide decomposes. This is, you know what, when I look at this question, I just see 36. I just see, wait, hang on a second. No, because it says mass of oxygen produced. Okay. No, that's cool. I reckon I could do that in my head. Wait, I'm gonna hazard a guess at this, only because I want to try and challenge myself. Okay. So 68 grams of hydrogen peroxide decomposes to produce 3.6 grams of water. Calculate the mass of oxygen produced when 68 grams of hydrogen peroxide decomposes. So notice that the difference between that and that is that one's times by 10. So how much water would be produced? Well, obviously that would be times by 10 as well. Because if 6.8 produces 3.6, 68 will produce 36. Yeah? Okay, so we've got 36. We've got 36 grams of water. Now, this is the interesting thing. If I have 2 lots of water, let's look at the mass of water. Okay, if you look at the if you look in your periodic table, water weighs 16, and there are 2 hydrogens because it's H2. So it'd be 16, 17, 18, right? So 18 is the relative molecular mass for 1 water molecule. but there's 36. Let's just pretend that's 2 water molecules there. Okay, so now if I want just the oxygen, I need to take away 4 lots of hydrogen. So I'm going to take 4 from 36, and I'm going to say that mass of oxygen is 32 grams. Let's see. Yeah, bruv. Bruv. I did that in my head. I feel like a bit like a genius now. Although I really shouldn't, because I'm a chemistry specialist. Okay, so yeah, just think positive. Yeah, think positive, think simple. I'm gonna keep this video. Hopefully the next videos will be shorter, because I want to try and keep them as short as possible. Anyway, I'll catch you later. Look out for more of my videos, and good luck for your revision. Just keep studying, and you will be fine. Keep moving forward.